This is question 1. It has 1, 2, 3, 4 parts. So part A is asking, what do you understand by the term abstract class in Java? What's an abstract class in Java? An abstract class in Java is a class that cannot be instantiated. Full stop. 2 marks. Okay, let me see if I can demonstrate this with code. An abstract class. Let's create an abstract class called abstract. And for us to make it abstract, we need to include the abstract keyword like that. So this becomes an abstract class. Now, to demonstrate the cannot be instantiated part, we need to abstract I misspelled abstract like that. So this refactors abstract. So abstract class called abstract class is equal to new abstract. Cancel. This is not what we want. This is something else. So this is where we usually instantiate classes. So we cannot instantiate an abstract class like this. This will cause compile time error. So abstract classes that have this keyword cannot be instantiated, but when you take it away, then the error goes away. It ceases to become an abstract class. So that's the definition of abstract classes. They cannot be instantiated like this. Then write down 2 ways how a class becomes abstract. 2 ways. Okay, 4 marks. Ha. So the first way we've seen is using this abstract keyword. Then the other way is when a class has abstract methods. So public abstract void abstract method like that. So this is another way a class becomes abstract. Now, when it's a okay, let me just copy this. Copy. Go back to how it was. Let me just create another class, another abstract class, abstract. Okay, so we have a normal class. It's not yet abstract. We don't have the abstract keyword. So now another way we can make this abstract is by declaring an abstract method. So once you have an abstract method inside a normal concrete class like this one, there will be a compile time error because an abstract method cannot exist within a concrete class. So to make this valid Java code, then we have to add the abstract keyword there in our class, making it abstract as well. So this is another way of creating abstract classes. So first you can declare it as an abstract class like this. That's the first way. Then the second way is if it has abstract methods. Let's try. What if it has, can it have abstract fields? I've never tried that one before. Maybe public abstract string called name. Can that happen? Okay, you can't have abstract fields. So those are the only two ways. You either have an abstract method, or you make the class itself abstract. Because by having an abstract method, you must make the class abstract for it to be an abstract class. Okay. Oh, there's another one here. Inherit an abstract method. Inherit an abstract method. Ah, nice one. Okay, that one. Okay, let's find that one. So we have. Let's make this abstract. Let's get rid of the error there. So we have an abstract class called abstract. So besides having an abstract method and forcing us to add the keyword here, what happens if we inherited from the abstract class like that? Nothing happens. Nothing happens. So this class cannot become abstract just by inheriting the abstract method unless there is something like this going on, unless you have an abstract method inside this abstract class like this. So once you have an abstract method, then this abstract method must be implemented, so it must be overridden, and you provide an implementation for it. And this is also not abstraction, like the class is not abstract. This is a concrete class. So there's only two ways. You either create an abstract method like we had done before inside a class, forcing it to be abstract, or you make the class abstract like explicitly. So this answer here, I don't believe. Oh, inherit an abstract method which doesn't define all abstracts. All abstract what? Yeah, okay, I think I get what they were on. So basically, if we go back, if we inherit the abstract method like this, get rid of this. So this is an abstract method because we declared it as abstract, but we are inheriting it. So to so we are inheriting the abstract class called abstract, and since there is no abstract method here that we have to override, since we can't, there's no abstract method here which requires to be overridden, like here now we are getting the error because it is forcing us to override and provide an implementation for this abstract class. So to avoid doing this, to avoid the overriding of this method here, the abstract void, the abstract method, we can declare this class as abstract as well and get rid of the error. Okay, so we have seen you can either declare the class as abstract, or you can include an abstract method which forces you to declare the abstract keyword, or if you inherit an abstract class, you must declare the class as abstract to avoid implementing the what? Any abstract methods within the superclass. Any abstract methods within the superclass. So to avoid implementing that method or any other methods, you need to declare the class as abstract. Which other way is there? How many ways are those? Those are 3 ways. You declare it as an abstract class, or you include an abstract method, or you declare it as an abstract class after inheriting from an abstract superclass. Which other way? those are many ways. 2 ways. Write down 2 ways. Okay, they asked for 2 ways. We have given 3 ways. Okay, part C. Assume that A is an abstract class. Okay. So let's create a class called A. Assume that A is abstract, and we make it abstract by declaring a keyword called abstract there. For each of the following, indicate true or false. Okay. Whether the code causes an error and give a reason for your answer. So we have an abstract class called A. The object is x is equal to new A. This will cause an error. It's true because we cannot instantiate abstract classes, just like we had seen previously with this guy here. You cannot do this. So consider this to be class A. We cannot instantiate it like this. So that is true. Let's prove it as well here. This happens in the main method. So abstract class A with the object x cannot be instantiated like this. That's an error. So that becomes true because abstract classes can't be instantiated. Okay, yeah, that's the reason. What's number 2? Number 2 is an abstract class with y as an array is equal to new A is equal to new A. Okay. So there's 2 ways to create an array. Let's first clear that. Arrays. There's 2 ways to create an array in Java. So you can, inside the main methods, we can either create an array like this, an array called array, new int, and then you give the array a size, like that. Or you can do this, this is how it's done in C as well, usually. So array simple. So you can do this is equal to new int, give it a size like that. So there's 2 ways to create arrays in Java. You can either include the brackets just next to the data type like this, or you can include the brackets after the variable name or next to the variable name like that. But this is the new modern way of doing it. And if you hover over this orange warning, you can see local variable array simple has C style array type declaration. This is how it's done in C, but Java can also accept if you do it like this. So it's not an error how it was done here. This is the old way of doing it. But when you hover here, of course, IntelliJ will prompt you to replace it with the Java style. So if you do that, then it rearranges it the way we've been doing it all this time. But this is also acceptable. But of course, it's simple. It's not simple. Recommended to use it this way because I guess most of everyone uses it that way. So this is an array. This here is an array of type A is equal to new this kind of array. So So this I'm going to say, will this cause an error? No, this won't cause an error. That's what I think. Give a reason why. Because we are creating an array of wait. Because you cannot instantiate abstract classes, so which means you cannot create objects of that type. And since we cannot create objects of this type, then that means we can't have an array of type A which is abstract. Okay, so the answer is true. This will cause an error. So let's try that. You see, let's try to create. It's here. So it is saying it is trying to create an array called Y with new like this. That is 3. So this should not. It is running. Hi. Wow. Okay. What is this one in? Okay. Why is this running? Okay, let's. What if we try it to print out the variable? Let's first get rid of this error so this code can compile. What if we printed it out like that? What happens? And what if we arrays dot toString import arrays.toString java.util.arrays. So if we run this, I want to save. What do I want to see even? Okay, this is what I want to see. So you can create an array. Wow. Okay, we have been proven wrong. You can create an array of an abstract class of type abstract class of type abstract. So this is false. For each of the following, indicate true or false. This is false. It is false because you can create an array of type abstract class. You can create an array. Yeah, that's false because wait, this answer here is false. This one is wrong because you've just shown you can create an array. So this can be used to create an array. So this should be false. And the reason, well, we can just say can be used to create an array, or what could be a more technical reason for this? Well, I guess that is the one we should go with. Can be used to create an array. Can be used to create an array. Because here it's null because we haven't initialized any variables, to be any objects rather to be in our array. So we could say something like the first object should be. Now this is where this is some other advanced concept called anonymous classes. So these values inside here will be constructed using anonymous classes. So So we could have no, not you. We could have what's this? What happens if we run into this? What should come here? Okay, nice. Okay, we have a weird looking string there. Okay, so it's no longer nothing. There's something is being created. Hmm? There's a reference to it, to this object, which is this weird thing. Hmm? This weird thing here. Anonymous class, abstract class A has this reference to some objects in memory which we do not know, but it was created using this anonymous class like that. So we can do the same for the second reference here. Let's try now. Let's not override anything. Cancel. We run that, so we should have another weird looking string here that references this object like that. So it is still of class A. And then we have that. Yeah. So it can hold values. It can hold arrays, elements. It can hold elements in an array. So yeah, this can be used to create an array. So here it's false. Reason can be used to create an array. Okay. Part D. Using an example of your choice, demonstrate polymorphism by using one abstract class that has at least one abstract method and two concrete classes that inherit the abstract class. The main method is not necessary in any of these classes. Demonstrate polymorphism. What is polymorphism? Polymorphism is having one thing but in different forms. Having something displayed in different forms. Poly means many. Morph is form. So many form polymorphism. Okay. Using an example of your choice, demonstrate polymorphism. Let's create one abstract class. Let's call it poly. The class is abstract, so we need to create a keyword to add the abstract keyword. Make it poly. Make it abstract. And this abstract class has at least one abstract method. Okay, so this abstract class has at least one abstract method. Public abstract. Void one. Let's call it one, like that. That's our one abstract method. And two concrete classes that inherit the abstract class. So I'm going to just write the two classes down here to avoid that many other files. So I'm just going to say class poly A, which inherits from the superclass is abstract, like that. And two concrete classes. So these are concrete classes. We don't have to include the word abstract to make them what? Abstract. They are concrete. What is happening here? This cannot be done. Okay, whatever. So anyway, we don't need to include it. So we have a class poly A which extends the superclass poly, and since it is concrete, this means that we have to override this implementation here. So override the implementation of public void one, override this method and provide an implementation for it. We are one. So when you're overriding the implementation here for any abstract method, you don't have to include the abstract keyword like this, because then it becomes abstract methods like end here, they have no body. So but if in our case here, when you're overriding, we must provide a body, and since we are providing a body, we don't have to include the abstract keyword anymore. So that's our first class. The second class is going to be called poly B. It's also extending the superclass poly, and we are going to do the same thing, override the what? The one methods, and let's call this I am, or let's call it the one. So you can do this here, because in Java, any Java file, in this case poly.java, any Java file must have at most one public class. So we can't have two public classes like this. This will cause an error. At most, you must always have one public class like that. What happens if there is no public class? Okay, nothing. But you can't have two public classes. There's always one class that has to be exposed as public in any Java file. Okay, but when you're in an exam, of course, you can do this, because these will be considered two files. If you're in an exam, this will be considered two files, so you can add your public like that. But for the case of making the code make sense or compile, let's avoid the public keywords. And where are we? The two classes inherited the abstract class, which I have done. We have inherited the abstract class like this using the extends keyword. The main method is not necessary in any of these classes. Okay, then that's the end of everything. That's all. That's all we had to do. Okay, so that's number one.